Okay, guys, in this video, we are going to take a look at projectile motion. And this time, what happens is that the projectile is not shot from the ground. It's actually shot from some height, and it's equal to 1.6. So here on my picture, the 1.6 is going to be what's called h sub 0. So I'm going to write that down. So h sub 0 is 1.6 meters. I also know that the initial velocity of the projectile, so that's denoted by v sub 0, that's 81 meters per second. And the angle, I'll actually call it A for angle because I'm going to use the Desmos calculator and I don't want to call the angle theta. So A is 56 degrees. It's customary to use theta, but I'll use A. Okay. And then the gravitational constant, you should already know what it is, but it is 9.8 meters per second squared. Okay, so with that, there are 2 points that we will be interested in. 2 points in time. Point number 1, that's when the object, whatever you're shooting, is going to hit the maximum height. So what should you know about this object? And this is something that you're going to need to memorize. So memorize or reason, whatever. So maximum height happens when the y component of velocity is equal to 0. Why is that? Because you can see that I drew the blue vector. That's the velocity vector. It has to be tangent. At the maximum, the y component of this vector must be 0, right? So you can see that it only has an x component, but not y. And in order to find what is going to be the maximum height, you would need to find the y coordinate of this point. So you will be plugging in the time when it reaches the maximum height into y. So maximum height, is ry. So into the y component of the position. And then the other point of interest is going to be when it reaches the ground. So it reaches the ground. This is when you look at this point right here. So what is special about this point? The x, which is this rx, that's not 0, right? But the y coordinate of that point is 0. So here, ry will be 0. And usually they ask you to find what's the range of the projectile. So they will ask you, what is Rx? That's range. Okay, so let's see how to find that. So I'm going to use Desmos throughout. So first, I am going to define all the components here. So the initial height, 1.6, initial velocity, 81, angle, 56. Make sure it's in degrees. G equals 9.8. Okay, how do I solve Vy equals 0? Well, there are formulas for the projectile motion. This right here is your Vy. So you're going to need to set this equals 0 and solve this for t, for time. But that's actually not that hard. So you're going to just take, so t, I'm going to call it t1 for the first time of interest. So on the top, I will get V0 sine A. On the bottom, I get G. Okay, so now I have the time. Okay, so this is my time. I solved it. So let me just write this down. So maximum height is going to happen when T1 equals V0 sine A divided by G. And I got something like 6.8522. Okay, so that's going to be your first answer here. Now, to find the maximum height, you have to plug in that value of t into ry. What is ry? This is it in my formulas. This is the y component of the position. So very easy, since I already defined everything. I'm just going to type it, right, just like that. And I'm using t1 because I just found it. So it's going to be g over 2 t1 squared plus h0. Okay, that's it. So I found my r, y, and that's going to be 231 meters 67. I'm not sure how many decimals it wants. It just says, looks like that's just 1. Okay, let me submit this just to make sure. Okay, then what is next is going to be the hardest part here, is to solve for when it reaches the ground, because we need to set the y component of position equals 0. But the y component of position is this right here. This is it. And it is actually a quadratic equation. So you're going to need to solve it by using the quadratic formula. So let me introduce the quadratic formula. So first of all, man, I cannot call the angle A because in quadratic formula I have to have ABC. Okay, let me call this A1 because ABC for quadratic formula. Okay, so it's going to be A is going to be the t squared coefficient. So that's negative g over 2. Okay, B is going to be the t coefficient, which is V0 sine A1, I'm going to have to call it. And C equals H0. Okay, so here for the quadratic formula, let me type it. First, I'm going to type the discriminant, which is b squared minus 4ac. And you can see that's a positive number. So I'm going to have solutions. Let's see. So the quadratic formula says negative b plus square root of d divided by 2a. And then the other one was going to be negative b minus square root of d divided by 2a. Only one of these solutions is correct. Why? Because the negative is not okay, because we're talking about time. So when we set this equals 0 and used quadratic formula, we got what? Well, we got the time. So this is by quadratic formula. And we basically used the computer to do it for us. And we got T2, which is the second time, equals 13.7282. No, actually 83 if you round it correctly. So I'm going to call this T2. Okay, so let me copy that number over here. Okay, and I don't know if it's going to accept it or not. That's 4 decimal places, it better accept it. Okay, maybe not, maybe I'll have to round it. Okay, so it did accept it. Okay, but whatever. Okay, so the last part is to figure out what's the maximum range of the projectile. So to get that, you have to find your Rx. So you have to plug in the t value you just found into the x component of the position. And the x component of the position is this right here. So that's not going to be hard. Wish this doesn't come up all the time. Okay, so we're going to get V0 cosine, and I called angle A1, T2. That's it. Okay, so that's my maximum range. And since it says just 1 decimal place, I think I can abbreviate that. All right.